All right, so 8.1, Introduction to Matrices, or a matrix, not the movie, but the mathematical principle. A matrix is like a grid or a. Sorry, I'm sick. I'm tired. All right, we're gonna get through this. We can do this. A matrix, rectangular arrangement of numbers in rows and columns. So I've got these normally won't be letters; they'll be numbers in some sort of a configuration. The horizontal value is where you get your rows, excuse me, and your rows are important because that's how we're going to distinguish what kind of matrix it is, along with your columns. To cover a little bit, each individual piece of a matrix is called an element. So we have row 1 here is A, B, C, row 2 is D, E, F. Now, when we talk about the horizontal measure, we have columns. Columns, I remember them because they're going up and down, and when you think of columns in a building, columns are going up and down. Okay? The columns have to be able to stand up and down. And when you think about rows of desks, they're going side to side. Hopefully that helped. So the way we talk about matrices is this one has 2 rows and 3 columns. So we say this is a 2 by 3 matrix. It's not a multiplication. It's not 2 times 3 matrix. No, it's a 2 by 3 matrix. Very much the same way we measure a piece of wood. It's a 2 by 4. It's not 2 times 4. It's 2 by 4. So don't get those confused. All right, we have on your cheat sheet quite a bit of information about matrices. Please refer to this throughout the lesson and throughout the week. It will help you immensely. Okay, so right here we talk about the columns. I give that to you on the cheat sheet. There's no excuse to not know what a row or a column is. Also, the Pythagorean triples are given to you in your answer sheet if you should so choose to use them. But the main point of this is to show you the rows and columns. Right, so when we talk about it, we talk about a row by a column. This is also on your cheat sheet. We talk about, let's look at the dimensions of this matrix. Matrix C, it's got 2 rows and 2 columns, so it's a 2 by 2. P, same thing. It's got 2 rows, 2 columns, it's a 2 by 2. Q, it's got 2 rows, 2 columns, it's a 2 by 2 matrix. E gets a little bit different. Notice how we have 3 rows and 3 columns. So this is going to be a 3 by 3 matrix. All right. But let's look at the last couple of them. We have here W is 2 rows and 3 columns. So notice the rows come first. So it's a 2 by 3 matrix. That's important. There's no ifs, ands, or buts about it. It has to be rows first, then columns. So this one now, we look at matrix Y. It's got 3 rows and 2 columns, making it a 3 by 2 matrix. You cannot choose what order you want to put them in. It has to be rows, then columns. That'll help you with problem 1 in the homework. There's kind of the culmination of what we talked about. Dimensions are not a multiplication. I can't say that enough. Because there's a difference between multiplying and different types of matrices. So when we add matrices, in this instance here, we're adding matrix ABCD plus matrix WXYZ. Notice how each element is added to its corresponding element. So A and W are added together. At the same time, B and X are added together. You just find each piece and add it together. The same is true of subtraction. You find the top left element and subtract it from the top left element. So A minus W. So to get some practice in with this, if you notice, we just look at each individual piece. 1 plus 0, 1. 2 plus 5, 7. 3 plus negative 1, 2. And negative 5 plus 4 is going to give us negative 1. So you're going to have a test question just like this. And with subtraction, I look at each individual piece. Okay, 5 minus 3, 2. 0 minus 2, negative 2, 10. And you just find each corresponding piece and you subtract them. Now, don't forget your integers. You're taking a negative 2 minus a negative 9, which gives you an addition sign, which makes it 7. So we go through here and we answer each piece individually, and don't forget it's minusing a negative, which makes it positive. That's going to trick up a lot of people. So let it be you. Subtraction of a negative is an addition. Okay, that's going to help you with 3, 4, 8, and 15. All right, so here's a question. Describe in your own words a matrix. Describe what it is, how to quantify it, what it looks like, all that stuff. In your own words, fill in this blank. All right, scalar multiplication. If a matrix is multiplied by a number, then every element of the matrix is multiplied by the number. Then the number is called a scalar. Okay, so this is called scalar multiplication. Back in similar triangles, we had a scale factor, which is what we multiplied everything by to get our new sized lengths. Here we're using scalar multiplication to say that if I have 5 times a matrix, that means that each piece is times by 5, no matter what. And don't forget, order of operations still applies. Multiplication still happens first. So if we talk about the scalar multiplication, again, we just look at each piece. 4 times 0, 0. 4 times 5, 20. And we end so on and so on. So we just have to times each piece. And then you're going to have a test question at about the same level of difficulty. I may combine them into one big question, but scalar multiplication is a big part of it. So I multiply each piece one at a time. Okay? And I'm not going to go very slow on this because you can do these. All right, -2 times -2, 4. Okay, we've been doing multiplication since third grade. You should be able to multiply numbers. That's going to help you with those homework problems. There you go. All right, so example 8.4, use the results of the previous examples to perform scalar multiplication and an addition and subtraction. So now, if you look here, I'm asking you to do this matrix plus scalar multiplication of 4 and this matrix. Well, I know that 4 times this matrix is 0, 20, -4, and 16. So I can overlay that on top. I can replace it. Now, once I've done the scalar multiplication, that's order of operations, right? Now I can do the addition. I add each element together, and I end up with my answer. So let's look at it from a different perspective. If I want to subtract, here's my first matrix. I'm subtracting 2 times each of these pieces in here. Well, I've already done the scalar multiplication for -2 times all of this. So there's my scalar multiplication. And notice how it became an addition problem. Because I distribute the -2 throughout everything, now I can add everything together. Part of the distributive property. So I get -1 plus -4, 9. All right, so you just got to add them all together. Don't forget that distribution. If you distribute the -2, make sure that you change it to an addition because you've already taken care of that subtraction problem. Apologize. All right, we're going to use the same example again later on. All right, so let's talk about how we multiply matrices. We've talked about multiplying a single number by a matrix, but now we're going to take 2 matrices. Matrix A is an m by n matrix, so it's going to be a 3 by 2 or whatever. Matrix B is an n by p matrix, so this number has got to be the same. They've got to be the same value, and the m and the p doesn't really matter. I'll show you about that in examples later, but right now you just got to understand that it's got to have the same number of columns as it does in rows. Okay, this principle is right here on your cheat sheet about matrix multiplication. You can see it's going to blow up right along here. This is your matrix multiplication and your dimensions by rows. All right, hang on, take a break. Okay, so the new matrix after the multiplication will be an m by p matrix, and that makes sense when I show you the rules of how to do multiplication. So if we look here, C times E, here's matrix C, here's matrix E. If I look at the numbers, the middle numbers are not the same. Since they're not the same, it's undefined. We cannot do this operation. We cannot times C times E. The middle numbers must be the same. Now E times C, same process. The middle numbers are the same, so we cannot multiply them. Now Y times E, middle number, still undefined because they're not the same. Now E times Y, look at that, the middle numbers are the same. The dimensions of the new matrix are going to be 3 times 2, or a 3 by 2 matrix. Okay, so when we do matrix multiplication, it's not like addition or subtraction. The way we do it is we have to multiply a whole row, namely AB. We take all of AB and times it by this whole column, WY. The way that looks is in your cheat sheet right here. Okay, notice how I have ABCD times WXYZ. I take A, B, and times it by WY. Here's AW and BY. So if I took this whole row and I've rotated it around to be WY, A and W would line up on top of each other, and B and Y would line up on top of each other. So you have to kind of rotate it around to be next to it. So that's why it's AW plus BY. And I add those together, and that's my top left box. Now I take AB times XZ. Here's AX plus BZ. And once I've done that, that's my whole top row is done. Now I go to the next row down. CD times WY. Well, here's CW plus DY. And CX and DZ goes right here. And that's our new matrix. It's a 2 by 2 matrix. All right, looking at it this way, you've got this. Now you can see it visually with little boxes. AB times WY. AW plus BY. AX, they match up in locations, and then BZ would match up in locations. CW, DY, CX, and DZ. Okay, this is how to multiply matrices. I'm going to give you test questions and ask you to multiply these two matrices together. And you're going to have to tell me, first of all, can you do it? Are the numbers, are the dimensions such that you can? And then you're going to have to actually perform it if it's possible. So, multiplying matrices looks complicated. I'll admit that. But it's not nearly as difficult as it appears. You just got to get used to the pattern and the rhythm. And once you see the pattern, you'll be fine. But you have to practice. Otherwise, it's going to be hard. Okay, so on the test, or on the homework, do it. And if you have questions, ask during class. We can cover it in class. But if you don't do your homework and you come to class, you'll never know what to ask until it's too late. So please do your homework and make sure that you come in and ask questions. All right. Okay, here we go. Here's a good example. I'm going to go through this fairly quickly, but notice 1, 3 times 5, 6. That becomes 1 times 5 plus 3 times 6. Okay, you're going to first multiply the row, first row by first column, and then add them together. That's how we get to 23. Next, you're going to multiply the second row, or the first row, times the second column. This is 1 times 0 and 3 times 7. Notice how we line those up. We multiply them and we add them together. Then we multiply the second row by the first column. Do the multiplication, add them together. Multiply second row times second column. Multiply them together and do the addition. So this is our final result. We just took those two matrices and we multiplied them together. And here's our new answer. Matrix multiplication. Very cool. All right. So for an additional example of how this is going to work, 1 times 5 is 5, plus 3 times 6 is 18. So 5 plus 18 gives us 23. And I don't have my stylus here with me, but essentially it's going to be 5. Let's see if I can do this. No, not going to let me do it. That's silliness. This isn't going to work without the stylus. You'll have to see this in class if you come. 5 plus 18. Look at that. All right, that was not worth the amount of time I spent on it. But you're going to take them and you're going to add those together. That's going to be the top left. 1 times 5. 1 times 5. Yeah, it's not going to work. I need my stylus. I'll do it later. Okay. Example 8.6. We're going to first find the dimensions of each matrix, and then we're going to see if we can multiply them together. All right. So W, the dimensions of W are by 3. Y was a 3 by 2. H is a 2 by 2. 3 rows and 2 columns. Now we're going to see if the combinations can be multiplied. So W times H. If you look up here at a W and an H, you'll see the middle number is 3 and 2. W and H, they don't have the same middle number. We can't do it, undefined. We look at W, H, and W. Now we switch the order, and now the middle numbers are the same. So now we can do this matrix multiplication. Now what would be the dimensions of the new multiplication? It's going to be a 2 by 3 matrix. Hopefully you guys can see where that comes from. It's right there on the board, all right? So if the middle number is the same, then the new matrix is the rows of the first and the columns of the second. WY, is it defined? Look, middle number is the same. All right. And that means that our new matrix that we've just formed by this multiplication is going to be a 2 by 2 matrix. All right. YW is defined. The middle number is the same. That means that our new matrix is going to have a 3 by 3 dimension. All right. HY, middle number is not the same, so it's undefined. Y times H, middle number is the same. Our new matrix will have a 3 by 2 dimension. All right, this example will help you with problem 2 on your homework. Okay, summarize what you learned. You should now be able to do 14 through 17 from your review worksheet. And tomorrow is the test. Or Tuesday, sorry, the 28th is the test. I hope this helps you prepare for the test. And do your homework, fill in your notes. And I will probably not be posting a video on the homework today. We'll see what happens.